This question comes from framework 4. Given the coordinates of the parallelogram, what are the coordinates of x, which is the intersection of the diagonals MT and AH? If it's a parallelogram, the diagonals bisect each other, which means they have the same midpoint. So pick either midpoint. I'll do A and H. Either diagonal and find the midpoint of the diagonal. That's where they intersect. So the midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Find the midpoint of A and H, and that's where the diagonals intersect. So that's -1 plus 7 over 2 and 3 plus 5 over 2. That's 3 comma 4, which is not an option. So 3 comma 4 is the right answer. Let's just get rid of all those options. This comes from framework 3. Which of the following is the measure of angle A, which would prove the two triangles are congruent? Well, if they are congruent, then all the angles would have to be the same. Angle C would have to be congruent to angle F. And angle A would have to be congruent to angle D. So if x minus 3 has to equal 22, means x equals 25. That's not what the question asks, though. So then we plug in 25 for x to figure out what this angle is up here. 100 plus 7 is 107. And then finally, we use the fact that 3 angles of a triangle always add to 180. We have 22 degrees plus 107 is 129 degrees. So 180 minus 129 tells us that this angle is 51 degrees. And so is angle A, 51 degrees. Question comes from framework 4. We have 4 coordinates here that make quadrilateral ABCD. This graph is counting by 2, so be careful when you're plotting these points. -2 comma 3 is right there. That's A. 3 comma 6. That's B. 8 comma 3. There's point C. And then D is at 3, 0. AC has a slope that is undefined and BD has a slope of 0. AC actually has the slope of 0 and BD has a slope that's undefined, so that's not true. Almost true, but not quite. The diagonals are vertical and horizontal. Yes, we have a vertical diagonal. Yes, we have a horizontal diagonal, which means this would be a rhombus because the diagonals are perpendicular, so that's true. And then all 4 sides have a length of square root of 34 or 4. So to figure that out, you just got to figure out how long one side is. If it's a rhombus, which we know it is, they all have that same length. So let's figure out how long that side is. We can turn it into a triangle and do Pythagorean theorem. That side's got a length of 3. This side has a length of 5. Which means The side length, the hypotenuse there would be 3 squared plus 5 squared equals x squared. That's 34. X squared equals 34. The square root of 34 is the length of every side. So remember, option A was really close to being true. They just had AC and BD flipped. If it would have said BD has a slope that's undefined and AC has a slope of 0, that would have been true. This question comes from framework 4. We're told that this is a rectangle and it has an area of 56. So that means base times height equals 56. So if B is over here at -3, -3, and A is at 4, -3, that has a length of, from -3 over to 4, that's got a length of 7. So does the top side, which makes sense because it's a rectangle. So if the base is 7, or the length and width, if you want to call it length and width, is 7, the area has to be 56, which means the height has to be 8, or the width has to be 8, so that you get the correct area. So if this is down here at -3, has to have a height of 8, or a width of 8. We'll make sure that that counts up to 8. 1, 2, 3, 4, 5, 6, 7, 8. That tells you how high it needs to be. It's at 5. From 5 to -3's got a difference of 8. So Z would have to equal 5. So you have the correct height, or the correct width, to get the area of 56. This question comes from framework 5 about scale factors. What is the scale factor of the projection if it takes 14 centimeters from an original of 35 millimeters? So scale factor, you always put the image over the pre-image. So the image is 14 centimeters. The pre-image is 35 millimeters. And we need to convert that so that's the same thing, because we cannot have centimeters and millimeters mixed up. So 14 centimeters, there's 10 centimeters equals, or sorry, 10 millimeters equals 1 centimeter. So that means that 14 centimeters is actually 140 millimeters. Now that they're both millimeters, that will be our scale factor, 140 divided by 35, which is 4/1, or just 4 for the scale factor. This question comes from framework 4. Join the points to form a parallelogram, and what is the area of the parallelogram? So if you join the points, you get that parallelogram. Since we have a flat side, that would be what I would use for the base. This has a length here of 11. And the height just needs to go perpendicular. So I would measure straight up right there to get the height, which has a height of 7. So if the length is 7, the height is 7, the base is 11, base times height, 77 is the area. This question comes from framework 5 about similarity. So if the only difference between the two triangles is a dilation of scale factor 3, that means the image A prime, B prime, C prime, scale factor is 3, so that's 3 times larger than the original ABC. So angle B is equal to angle B prime. Yes, the angles stay congruent. The angles do not get multiplied by 3. The triangles are similar. Yes, that's true, as dilation does create similar figures. And then last we have B prime C prime is 3 times the length of BC. That is also true. Side lengths get the scale factor. This question's also from framework 5, with some rigid motions in there. So we're looking for similarity transformation. So we're trying to map LMN onto ABC. So starting with LMN, to get it up there to ABC, to get it in the right orientation, we have to rotate it 90 degrees that way, which is clockwise. Which is not what option A is saying. A says counterclockwise. But a 90-degree clockwise rotation is the same as a 270-degree counterclockwise. So that will be part of it. So when we do that, the rule is xy goes to y negative x. So let's take this point M right here, which is -2, -6. That's going to go to the point -6, comma, +2. So that maps M perfectly onto point B. That would map N right there and L 1, 2, 3 units up. Maybe 2.5 units up, it's hard to tell. Now, to get it to map onto ABC, it needs to get larger. So we're going to dilate it with a scale factor of 3 would work. Centered at the right angle, that would be perfect. Since it's getting larger, we need a scale factor of 3, not a scale factor of 1/3, because that would make it even smaller. Number 23 comes from framework 5. We have two right triangles, so they each have a 90-degree angle, and they each have a 53-degree angle. If the angles are, if they have two angles that are the same, they must be similar, specifically because of angle-angle similarity. Very similar question, that's why it's here on the same page, also from framework 5. Scalene triangles don't have to have anything in common. Right triangles will only be similar if you know another angle. Equilateral will always be similar. Two equilateral triangles will always be similar. So this question comes from framework 8 about volume. If a rectangular prism has a volume of 102, that means length times width times height is 102. What are the possible dimensions? So you check each of these dimensions and see if you get 102. So do 17 times 18 times 4 inches, which would be 4/12. 3 inches would be 3/12. 3.5 inches would be 3.5 over 12. And 5 inches would be 5 over 12. So just multiply all the dimensions and see if you get 102. First one you do. The second one also. The C, you get 104.125, so that's not quite close, but not quite. And then last, 17 by 27, you get 191, so that also does not work out. This comes from framework 5, about a directed line segment, splitting it into a ratio of 2 to 3. So that means that there are 5 total pieces that this is cut into. When you're doing splitting a directed line segment into a ratio, you have the ratio is 2 to 3. There's 5 pieces total. So what you do is you take those 2 points and the ratio 2 to 3. The 2 gets multiplied to the first point, or to the second point, and the 3 gets multiplied to the first point. So you get 6 and 12, 16, 20. So we're going to add our 2 x points, 6 plus 16, and divide by 5. And then we add the 2 y coordinates, 12 and 20. And also divide by 5. That's 22 over 5 and 32 over 5. What would the value of x need to be to prove that these unmarked sides are parallel? It would create the proportion 5 over 4 equals 8 over x. You cross multiply 5x equals 32. which is 6.4, which is A. So this question comes from Framework 5. With her standing right here, it creates two similar triangles. We have triangle with 3 by her height, which is 5 feet 5 inches. And then we have the whole triangle, which is 8 by the height of the room. Now the question says, how many inches will Sarah have between the top of her bed and the ceiling? So I would change this 5 feet 5 inches to just inches, which would be 5 feet is 60 inches plus 5 more makes 65 inches. You can also change the 3 feet to be 36 inches and the 8 feet to be 96 inches. And then find the height of the room in inches. So to do that, you would have 36 over 65 equals 96 over H. So you multiply 96 times 65 equals 36H. So divide by 36, you get the height is 173.3 inches. And then it says that she has a bed that's 7 feet tall. How many inches will be between the top of the bed and the ceiling? So if the bed is 7 feet, that's 84 inches. So then you subtract 173 minus the 84 inches. Tells that there's 89.3 inches between the top of the bed and the ceiling. This density question comes from Framework 8. You can use that mass equals density times volume. So we have silver, and we're going to also have aluminum. And we want them to have the same mass. So we're going to take the density times volume of silver times the density times volume of aluminum. The silver figure has a volume of 1,600, and we're solving for the volume of the aluminum. So 1,600 times 10.49 then divide by 2.7. You would have to have 6,216 point, around up to about 0.3 cubic centimeters of aluminum to have the same mass. And this question comes from Framework 5. If you're going with a scale factor of 3/4 about vertex A, trying to find the coordinates of C prime. So to get from A to C, you have to go up 4 and over 7. We want 3/4 of that. So 3/4 of that increase there of 4 would be 3. 3/4 times 4. And 3/4 times 7 is about 5.25. 1, 2, 3, 4, 5.25. That's where C prime is going to be. So if you count those coordinates, it's up 1, 2, 3, 4. That's our y coordinate. Our x coordinate, remember this is 0.25 over, so 9.25.